Good day, the topic is fluid pressure. Let us consider what is pressure or unit pressure. Pressure is the distributed force over an area exerted by a fluid on a body of surface, either uniform or varying, and directed perpendicularly on the surface. And in formula, P is equal to F all over A, where P is the pressure in Pascal, PSI, or PSF. F is the resultant force, N or pounds, and A is the area exposed or directly in contact to fluid in square meter, square inch, or square foot. Next, let us consider the Pascal's law. It is a principle developed by French mathematician and physicist Blaise Pascal. And for this Pascal's law, at any point in a fluid at rest, the pressure is the same in all directions. For example, a triangular prism is exposed to a liquid at a certain level. Pressures are constant, thus P1 is equal to P2 equal to P3 equal to P4. So for the notes, pressure is the same at any depth for a homogeneous fluid. For layers of fluids, at a certain line or depth, the total pressure is uniform, and the uniform pressure is acting perpendicularly to the surface. Next, let us consider the three classifications of pressure. First is the atmospheric pressure or PATM. So it is the pressure due to weight of air in the atmosphere on every surface with which it comes in contact. And it is measured by barometers, such as mercury or aneroid barometer. So under normal conditions at sea level, the atmospheric pressure is equal to about 101.325 pascals or 2,116 psf or 14.7 psi. On the other hand, if we are dealing with pressure head at normal atmospheric pressure, it is about 29.9 to 30 inches mercury or 760 millimeters mercury. So as shown in the figure, so we have now a mercury barometer. Second classification is the gauge pressure or P gauge. So it's designed to measure intensities of pressures above or below the atmosphere. And for gauge pressure, it is otherwise a confined pressure. And this is measured by manometers. So for the term vacuum, so it is any space having a pressure less than the atmospheric pressure, or otherwise, this is a negative gauge pressure. And for the free liquid surface or FLS, it is the surface of the liquid exposed to the atmosphere. And since it is exposed to the atmosphere, it is now an unconfined pressure in which gauge pressure is equal to 0. And for the third classification, that is the absolute pressure or P-abs, defined as the positive pressure above absolute zero or otherwise the zero pressure. And it is a combined gauge and atmospheric pressure. In formula, that is P-abs equal to P, that is the gauge pressure, plus PATM or the atmospheric pressure. So for the relationship of the three classifications, consider the reference of gauge pressure, which is the atmospheric pressure or PATM. The gauge pressure might be above, that is the positive gauge pressure, or below the atmosphere, which is a negative gauge pressure, or under vacuum. So to determine the value of absolute pressure for sample points 1 and 2, let us consider the absolute reference, which is the absolute zero. Again, zero pressure. The absolute pressure for point 1 is the combined atmospheric pressure and positive gauge pressure, while the absolute pressure for point 2 is the combined atmospheric pressure and a negative gauge pressure. So for the variations of pressure now, or otherwise, this is the derivation of our equation. So let us consider a sample column prism with point 1 at the top and 2 at its bottom, with A as the area of each section and H as the height. Next is to identify the forces. So again, we have A as the area and H as the height. So for our forces acting on this sample column, we will not consider the horizontal components since the forces will be eliminated or the forces are equal at same levels. For the vertical, let us consider the weight of the sample liquid prism and the resultant of pressure at the top, which is the weight of the liquid above the prism or above point 1, represented with F1, and resultant of pressure below, which is the reacting pressure to balance the system, represented with F sub 2. Apply equilibrium equation, that is the summation of forces vertical equal to 0, wherein the upward force is equal to the downward force. Combine the resultant forces at the left, thus positive F2 directed up minus F1 that is directed downward, and equal to the downward force, which is the weight W. From the equation of pressure, that is P equal to F all over A, cross multiply A, thus F is equal to P times A. And from the equation of unit weight, that is gamma equal to weight all over volume, if we will cross multiply volume, we have the equation for weight as gamma times volume. And our next interest is, what is this volume? So the volume of our sample prism is equal to the area of the cross section multiplied to the height of that prism. Next, since we have already the values of our W, or the equations for W, volume, and F, let us now replace F with P times A and W with gamma times volume, wherein the volume that is A times H. Divide both sides of the equation with area A. The difference of pressure at points 2 and 1 is equal to gamma times height. So with respect to this analysis, for the different cases, if point 1 is at free liquid surface or FLS, the pressure at FLS or P1 is equal to 0. Because again, we are dealing with gauge pressures, and the gauge pressure at point 1, which is the free liquid surface, is equal to 0. The pressure at point 2 or any point below free liquid surface, therefore, is equal to the gamma times the height. So it indicates that as the depth of fluid increases, the pressure increases because the value of our H is, or the pressure rather for P, that is directly proportional to the depth value H. So for example, when you intend to dive in a body of water, as you go deeper, you will feel the increase of pressure in your head. Next, if points 1 and 2 lie on one elevation or level, then H is equal to 0. Thus, the pressure at 2 is equal to the pressure at 1. And for the pressure head from first case, if we will cross multiply the value of gamma, the pressure head H is equal to P all over gamma. So let us now take our sample problems. So for sample problem number 1 in page 20, determine the pressure on the face of the dam at a point 40 feet below the water surface in pounds per square foot and pounds per square foot absolute. So given, and for our requirements are, so we have for letter A, P gauge in PSF, and for B, we have P abs, that is PSFA, or the pounds per square foot absolute. For the solution, for letter A, since we are dealing with problem of pressure identification below free liquid surface, then we will use the equation P is equal to gamma times height, where gamma of water in English is 62.4 pounds per cubic foot, and H below free liquid surface is 40 feet. Thus, the pressure P at this point is equal to 2,496 psf. Next is for B, and to be consistent with the units, consider the standard atmospheric value, that is 2116 psf. So using equation of P abs as the sum of P, that is the gauge pressure, and PATM, the standard atmospheric pressure. So substitute the gauge pressure from letter A and the standard PATM. The value of the absolute pressure is 4,612 pounds per square foot absolute. Next, for problem 7, at what depth in a standpipe containing water is the pressure 30 psi? So for the given, at a certain point of the standpipe, the gauge reads 30 psi. The required is what is the corresponding depth? H. For the solution, pressure head H is equal to P over gamma, or the unit weight, where P is 30 pounds per square inch, and convert this to square foot, divided by, so we have our gamma of water, that is 62.4 pounds per cubic foot. Thus, the equivalent pressure head is equal to 69.231 feet of water. Next, for problem 11 in page 20. So what is the pressure in pounds per square inch 4 feet below the surface of the liquid of specific gravity of 1.5? If the gas pressure on the surface is 0.4 atmosphere. So we have the given, and for our requirement, which is our pressure at 0.2 in psi. So for the solution, convert the pressure of gas at the surface of the liquid to gauge pressure, wherein P gas is equal to the absolute pressure minus P ATM. So the pressure of gas is equal to 0.4 atmosphere, then multiply that to our standard values. So for every 1 atmosphere, we have 2116 psf. Then minus the standard atmospheric pressure, which is 2,116 psf. Thus, our P gas is equal to a negative, or under vacuum pressure, 1,269.6 psf. Updating the value of pressure of the gas at the surface that is under vacuum equal to negative 1,269.6 psf. So next, determine the unit weight of the fluid. From the equation of specific gravity, gamma is equal to S times gamma of the standard or reference fluid, which is water, wherein S is 1.5 and gamma of water is 62.4 pounds per cubic foot for English system. Gamma, therefore, is equal to 93.6 pounds per cubic foot. So using the equation of the difference of pressure equal to gamma times height, rearrange as P2 is equal to P1 plus gamma times height. Substitute P1 as the P gas value, so the negative 1269.6 PSF, then add to the gamma of water that is 93, or the gamma of the fluid rather, that is 93.6 pounds per cubic foot, then multiply to the H that is 4 feet. Therefore, P2 is equal to negative 895.2 pounds per square foot, and convert this to PSI. Therefore, P sub 2 is equal to negative 6.217 PSI, and rewrite as positive 6.217 PSI. So by removing the negative sign, so we will now replace this with the word vacuum. So again, for your final answer, please do omit the sign and replace it with vacuum word. And for our next problem, problem 14 in page 20, a pressure gauge on the discharge side of a pump reads 43.5 pounds per square inch. Oil with specific gravity 0.82 is being pumped. Compute the pressure head in feet of oil. So for the given, at the discharge pipe, the pressure is 43.5 psi. The requirement is H in feet of oil. So for the solution, solve first the unit weight of oil using the modified equation of specific gravity, that is gamma of oil is equal to the specific gravity of oil times the reference fluid unit weight, that is gamma of water. Then S, that is 0.82, is multiplied with gamma of water, that is 62.4 pounds per cubic foot. Therefore, the gamma of oil is 51.168 pounds per cubic foot. So for pressure head, H is equal to P all over gamma, or the pressure all over the unit weight of that specific fluid. Substitute the pressure, that is 43.5 psi, and convert to PSF. Then divide this with the gamma of oil, that is 51.168 pounds per cubic foot. Thus, the equivalent pressure head is equal to 122.42 feet of oil. Okay, so that's it for fluid pressure. Take care and God bless.